Namaskar. I welcome you all to this class of mathematics. Today we are going to discuss Venn diagram in set theory. Set theory, last time also we discussed, you must have learnt that it's a quite easy course, easy subject, easy to understand, but a Swiss scientist mathematician Euler, he gave the idea of representing the sets by diagram. Now later on another British scientist Venn, he simplified it and now it is popularly known as Venn diagram. You might be familiar with Venn diagram. It is very simple to use and either you know or don't know, you will enjoy it. So please listen how sets are represented diagrammatically. You know universal sets, the sets under study, the set which has all the elements of other sets, or you might say that other sets are subset of the set, is called universal set. We represent universal set by a rectangle. So, let us say this is a universal set and it is represented by this rectangle called U. Now, other sets within this are represented by circle. So, suppose this is set A, this is another set B. So, sets are represented by circle. The size of circle does not matter. It may be small, it may be big, but it does not mean anything. Only thing we can see in this diagram that nothing is common between A and B. So, this represent A intersection B is equal to phi. Phi is an empty set. So, in set theory, last time we learnt that we represent it like this. Now, let us see another example. Say this is universal set and then two sets A and B are there, but now they have some common element. So, these elements are common. So, here A intersection B is not equal to phi. It is not empty set, because there are some common elements in A and B, and this portion is A intersection B shaded portion. Now, suppose that two sets are there, A and B, out of which A is a subset of B, then how do we represent it? So, let us say this is universal set and then A this is B, another set within this is A. So, A is a subset of B. Here A is a proper subset of B. Similarly, you can draw B is proper subset of A. This is A, this is B. So, B is proper subset of A. Now, there are some set operations. Friends, you will find that with this Venn diagram, the set representing set operations and then solving problems becomes very much easy. So, but there are some rules you have to remember. The first operation is union. Very simple. It is similar to addition in arithmetics or algebra. So, if there are two sets A, if we want to add, then we write like this: A union B. How do we define that? How do we define this? X such that X is an element of A or X is an element of B. Through Venn diagram, how can we represent suppose this is universal set This is A, this is B. So, A union B will be this complete shaded portion. This will represent A union B. Suppose A is equal to 2, 3, 4 and B is equal to 1, 2, 5, 6. So, A union B will become 1, 2, 3, 4, 5, 6. Here A is 2, 3, 4. 2 is common, it is in A also in B. So, 2, this is common element here, and then 3, 4 are here and 2 is there, 1, 5, 6. So, if we do union, so you can see that A union B is this complete 1, 2, 3, 4, 5, 6. Similarly, you can solve the problems of union. Another operation on set is intersection. It is we cannot say that it is similar to subtraction or multiplication because it is entirely defined a new set of operation on sets. Let us see. I am repeating these things. You must have learnt this in your +2 mathematics also. A and B are two sets. So, their intersection is called A intersection B, and if it is equal to phi empty set, it means that there is no element common in A and B. So, we say that these are disjoint set. So, if there are no common element, then it is called disjoint sets. How do we represent it? This is universal set. This is set A. This is set B. So, common area is this one. So, this is called A intersection B. suppose the case is that there is no common element in A and B, then we say A intersection B is equal to phi empty set, and this is called disjoint set. Now, next is complement of a set. These are very simple things, so I am not giving example. You will find example in the book and you can correlate it. Complement of a set, suppose A is a set, so its complement is represented by A dash or A bar, or we also write A C. How do we define it? Suppose there is a universal set and another set A is there. This is A. So, what about A dash? Complement of a set will be all the elements of universal set except the elements of set A. So, this shaded region is complement of set A. So, how do we define that? A dash is equal to x such that x is an element of U, but x is not an element of A. This is the definition of complement of set A. So, let us take a simple example. Say universal set is 1, 2, 3, 4, 5, 6, 7, 8, 9. This is the universal set. Now, set A is equal to 4, 5, 6, 3 elements are there. So, what will be A dash? Complement of set will be 1, 2, 3, 4, 5, 6 will not be there because these are elements of A. Now, the rest 7, 8, 9. So, all these elements will be there in the complement of the set A. Now, let us see what will be the difference of set. Suppose A and B are two sets and we have to find out difference of A and B, say A minus B. Difference of set, say A and B are two sets. So, what will be A minus B? We define that x such that x is an element of A but x is not element of B. How do we represent it? Suppose this is universal set, this is A, this is B. So, what will be A minus B? A minus B will be this portion. Because whatever there is in B will not be there in A minus B, but all the elements of A except the elements which are present in B. So, this is representation of A minus B. Similarly, what will be B minus A? This is universal set. This is A, this is B. So, B minus A will be this portion. B minus A. So, friends, these are the few operations you have learnt. Now, we will continue in the next class. Thank you.
We wear clothes on a daily basis. But have we ever wondered, where do our clothes come from? Who makes our clothing? And who are the people and the process responsible for the whole manufacturing of our clothing?